right, ready to go?
All right, I'm starting the show. Got a little bit of music just to make it fun. We are live. We are on the air. We are recording. Good morning, good afternoon, good evening, wherever you are in the world. Welcome to the DataView show. This is episode number 4. Today we're talking about Db2 LUW performance tips and tricks. I'm Scott Hayes, lifetime IBM champion and IBM Db2 Gold consultant, and your voice of the IBM community. So excited to be bringing you Raghu Sharakuru. I hope I pronounced that correctly. How'd I do, Raghu?
That's excellent, Scott.
Well, thank you. Raghu is a senior DBA at a company in the northern Midwest that he would like kept confidential. But you can read his blogs and you can follow him on Twitter. There's Raghu on Tech. How are you today, Raghu?
I'm doing excellent, Scott. How are you?
I'm doing really good, thank you. I'm glad that we got our audio issues sorted out, and I hear that I sound good today, which is an improvement over the last show. Tell us, our huge audience all around the world, tell us something personal about you, hobbies, interests, family stuff, whatever.
Something interesting. I mean, I'm passionate about music, so I bought this guitar like 2 years ago, but haven't played on it a single day. so hopefully one day I'll get to pursue my passion in music and maybe play an instrument. And then other than that, I love to run a lot. I see you run a lot, Scott. I haven't run a marathon yet. I did a half. And I swim a lot, and I work a lot.
You swim?
So other than that, I'm having a great time with my 2-year-old son right now. So he's our world.
That's great. That's great. All right. Well, you have a lot of content to share today, so we're going to giddy up and move along. This is the required gibberish. The opinions expressed are that of Scott Hayes and the show guests and do not necessarily reflect that of IBM Corporation or the IBM community. That's the disclaimer. Db2 is a registered trademark of IBM, which is also a registered trademark of IBM. We make no claims to any marks belonging to anyone, and this event is being recorded. Replays will be publicly available. Mind your manners. What's ahead? A couple of news bits. We'll have Raghu's awesome presentation, a couple of polling questions for you, and then we thank everybody like we always do. Coming up, 5th of December, Paul Z is talking about AI and Watson. He's an amazing presenter, been on TV, written 19 books. You don't want to miss that one. 19th of December, Peter Coleman. He is like the tools guy up in IBM Toronto. He's going to present the new Db2 console. That's what's next after DSM. The 9th of January, Thomas Chu and Matthias Funk. Those are some top Db2 guys up in Toronto. They haven't told me what they're going to talk about yet, but it's going to be great. And on the 23rd of January, Ember Crooks is going to talk about HADR in the real world, and you know that she's been to the School of Hard Knocks on that, and we'll have many valuable tips to share with you. So check the show schedule and make sure you've gotten registered. Here's some URLs to visit. Make sure you've gone to ibm.com/community and signed up to participate. That's a great information resource for IBM professionals. There's a Db2 Augmented Data Explorer. That's a very cool tool. You want to check that out. The IBM Db2 samples are now published on GitHub. You can try out the new data management console by going to ibm.biz/db2console. There's a free book on using DB2 with JSON at ibm.biz/db2json. iDoug, hey, let's not forget visiting the iDoug site. There's a lot of blogs there, articles, information, premium memberships, news about upcoming conferences, and of course your early bird discounts for registering for upcoming conferences. And as of the last show with Al Martin, I learned about the Watson Studio Auto AI, and that's really cool. There's the URL, so you can check out Auto AI. That's worth a visit. All right, let's get Raghu on the air and have him do some presenting for us. I'm going to make you the presenter, Raghu.
All right.
Click that button. We'll see your amazing presentation.
1 second. All right. Can you all see my screen?
I'm waiting. All I see is a blank white spot at the moment.
Oh, really? Let me know when you're able to see my screen.
It's funny, we tested this about 10 minutes ago, didn't we?
Absolutely.
All I see is you don't have two monitors, do you?
No, I just only have one monitor.
Oh. I don't see your screen. Are you in presentation mode or just showing the desktop? What's going on?
I'm showing my Keynote. So that's an app on my Mac. So that's exactly what I did earlier.
Well, I'm gonna make me the presenter.
Okay.
Make me the presenter, and then I'll make you the presenter again. You can try again. Make presenter.
Okay.
Fingers crossed.
How about now? Sucks. Your voice is breaking up.
Oh yeah.
So now it's better. Oh well.
I don't see your screen.
How about this? How about
there.
now?
Now we see something.
Okay. I basically shared my whole thing instead of just the Keynote. For whatever reason, it worked earlier, and now it's not working.
Okay, you're on the air.
All right. So this is a little bit about me. I'm Raghu Cherkuru, and I've been working with DB2 for close to 13 years. Started with 8.1, like before a lot of the mainstream features today, like HADR and STMM were not part of DB2 at the time. Apart from DB2, I do some coding. I like to code in Perl, Java, and to some degree in Python, and I love to tune SQL and performance tuning in general. And I blog at raghuontech.com, and I was selected as an IBM champion for 2019, and so I'm still a rookie, and I live in Wisconsin. So let's get started to the core of the presentation. So these are some of the things that I will be covering today. There is quite a bit, so I'll try to go a little bit fast. So to get to the end of the presentation, so feel free to ask any questions at the end. So we're going to go over the general best practices, some of the monitoring and tools that you could use to tune and monitor the performance of your DB2 environment, some reporting using some WLM data. We'll go over some PureScale specific tips and partition environment specific best practices. We'll look at some sorting and tips and SQL tuning. So what is a good performance? Like good performance boils down to two things really. One is like good response time and throughput. So you have a better response time, you have better throughput. So Lower the response time is, the greater the throughput. So if the higher the response time, your throughput goes down. So they're kind of inversely proportional. So you try to increase the response time of your DB2 servers to really make your system perform better. Some things like intangibles like happiness of the users and businesses is the ultimate goal of performance tuning. So some of the general best practices, GBP means your general best practices, not global buffer pool. So I had the shortcut in there. So one of the key things is like when it comes to performance, there are like a couple of things where things get really blocked because there is only single process or thread running in the DB2 system, and there are other areas where multiple processes run in parallel. Like for example, in a DPF environment, when you're using intra-parallel, a query can be serviced by multiple sub-agents. But unlike those parallel things, there are some things that serial. That means there is only one thing in your DB2 system that can potentially cause a bottleneck. One of those is the log buffer. So you need to have a good enough size log buffer as a attached transaction log disk for your transactions to run smooth and fast. You could measure the performance of your log buffer, and usually the log write time for I/O should be less than 3 milliseconds. As you can see in the screenshot, my system is less than 1 millisecond, which I'm pretty happy with those numbers. Another thing that I look for is, so the log buffer gets flushed due to a couple of reasons. One is when an application issues a commit, and another one is like when it gets full. So you don't want your buffer to get full a lot of times, and the other transactions needs to wait just so that the buffer gets flushed to the disk. So these are a couple of SQL that you could use to monitor those two metrics. And then locking is another area where things get to serialize on your system. Incompatible locking serializes the request, and as a result, your throughput goes down and your response time increases. So these are some of the tips that you can use. I actually recommend these things because I have seen people using wrong isolation levels and causing issues and not issuing the. I have seen in an application where actually as a bug, they forgot to issue a commit for one of those transactions that actually hold up their application. So don't keep the transactions open longer than they need to be, and use the least restrictive isolation the application needs. And there are a number of ways to monitor the logs, and there are a couple of SQL right up there to monitor the logs and log weights on your system. And if you really want to dig in a comprehensive way to monitor the logs, you could use the new Java-based event monitors. Check them out; they're really good. They need a couple of monitoring switches to be enabled at the database configuration level, like block time mode and mon date lock. Set them to history and values if you want to capture the values of the bind parameters and the history of the SQL statements that are part of the transactions. I believe they will capture 250 SQL statements with the history and values that are part of the transactions. OLTP general best practices, try to use the parameter markers because the repetitive compilation of the same query is going to kill the CPU. They'll also improve the package cache ratio. There are some vendor products where I have seen some problems in the past where they were using literals. Really, they should be using parameter markers. So IBM DB2 has a solution to those sort of situations. You need to take a look at statement concentrator in those situations. If those simple statements with literals are killing your CPU, definitely take a look at the statement concentrator DBCFG. And if the problem is the other way around, if your SQL statements are simple enough, but there are edge cases where some of them are not really using the optimal access path because of the ununiform data distribution or complex predicates or whatever, then try to explore the reauth always. It can be done a couple of ways. One is like finding your CLI packages using that reauth always and make the queries reauth on every execution, or specify that CLI package on the JDBC connection string, and then any SQL coming from that connection will always be re-optimized. Or I believe we could also use stored procedure.
Hey, Raghu.
This is another thing. Hey, Scott.
One question that always comes up, people want to know if a PDF handout can be available of your presentation. People are going to see all the SQL you have in your presentation, and they go, oh, that's really cool SQL, I want that. Would it be all right to
Sure.
Would it be okay to make a PDF available of your presentation?
I will make it happen, Scott.
Okay, I'm going to work on it while you present.
Okay, awesome. Yeah, thank you.
Carry on, my friend.
Okay, sure. So these are some of the best practices related to the event monitors. They are a great way to troubleshoot problems, but do not create indexes, especially when they are active and writing to the tables, because that's going to slow down your transactions. What you don't want is you don't want to slow down your already slow system or slow database. If you want to create indexes to analyze the data, like turn off, deactivate the event monitor or move the data over to a different system and start analyzing the data. A federation is another thing where I have seen a few times in my career as a DBA. It's been used in a wrong way. In my humble opinion, federation and performance really do not belong in the same sentence because it limits a lot of capabilities of optimizer, and they don't really reside locally. So there is a lot of network and optimization limitations for the DB2 optimizer. It should only be limited to small lookup queries or like very non-trivial, non-critical stuff. So you could create indexes on nicknames, but they're not actually materialized locally. They're just a specification. They're kind of act as a hint to the optimizer. Hey, these indexes exist on the source side, and at the same time you could update the run stats on the nicknames by using the sysproc.nnstat stored procedure. Try to avoid them in critical transactional systems. So if you try to do an experiment, this is one of the SQL that I was tuning. Someone is expecting a performance out of this query. I was trying to explain why these things are not going to perform, because you see those ship operators. So that means the rows are being shipped. So for every, you see on the bottom right of the plan, for every row in the TES local table right there, it's going and doing a scan on the trying to match a row on the right side that belongs to a nickname. So that's not going to perform really. So monitoring and tools, really, I mean, these days I'm a big fan of mom-get table functions. They literally give me anything that I want. And activity event monitors are great to troubleshoot any issue in depth. Mom-gets are like kind of a snapshot, but you could write some scripts and create some stored procedures or whatnot to gather some historical data and perform some trending on that data. And I personally use WLM. That's a great way to, they kind of give the best of both worlds. Try definitely investing some time on WLM if you can, because we found it tremendously helpful with our implementation in our environment. It kind of gives the advantage of the activity event models at a granular level, and also you can perform some long-term training of performance numbers as well. And if you don't have any predefined monitoring scripts, if an issue is happening right now, take a look at using DB2 Mon. It's a Perl script. It runs like you can specify the customized interval. Like you say, hey, DB2 Mon, just run it for the next 60 seconds and give me the what's the bottlenecks in my on my database server, and it will create a nice report on different top 10 metrics. Check it out. There's a link in there. And if I had to go to a database to tune a DB2 system, this is what I call a gold mine query. This is something that I believe Steve Reese wrote. He's the performance, he's not with IBM anymore, I believe. This is something that I got from his blog. So this is something that I use almost on a daily and weekly basis. So by using this query, you can grep for any metric available in the database. So if I'm trying to monitor something on the disk-related stuff, I/O-related stuff, or CPU-related stuff, I run this query and grep for CPU, and it will give me all the available table functions on the columns that have that string in there. So it's invaluable. If you are monitoring and tools, if you are troubleshooting a disk performance issue, take a look at if you are running on Linux or AX. IOStat is a great tool. IOStat-xcc is a Linux specific command. It provides the extended statistics. And dstat command, I really like it because it's written in Python and it's nicely it has a lot of colors to it and it provides best of both worlds of IOStat and VMstat, and check it out if you haven't checked it out. Within DB2, to specifically troubleshoot the IO issues like mon-get table space, mon-get table, and mon-get index are great friends. Once you identify those tables and indexes driving the IO, you can identify which tables reside there, and then you can query the mon-get package cache, or even activate an activity event monitor, and try to find the queries that are accessing that specific table. And then another thing is that I noticed is mon-get package cache statement. If your IO is being driven by a view, you may not be able to find that in the mon-get package cache statement because your mon-get table is saying that this specific table is driving the IO, but if somebody is referencing the table to a view, you might need a different way to capture those SQL statements. So this is where usage lists will really help you. They were introduced in 10.1. I think they're pretty cool. If nothing conclusive, if you can't find a specific SQL, if you can narrow down to a specific SQL, it might be that specific SQL or any other process that's driving the IO. It might be that your buffer pool might be too small. But you could use some of these SQL. These are some things that there are a lot of variations of that SQL that I use, but these are some of them. If I want to get number of table scans, the first SQL will help. It will list the tables in your database sorted in descending order by table scans. And the second query will give us the table spaces that's responsible for the most IO on your DB2 system. And the third one is mon-get package cache at the statement level, what's driving the most IO. Another thing is mon-get package cache and the activity metrics are really great these days because if you're troubleshooting a slow query or something like that, if you are trying to capture different weight metrics for that SQL, I don't think there is a better way to troubleshoot than mon-get package cache statement or activity metrics. I use this a lot in PureScale. You can check for CF wait time and the reclaim wait time. If you are in a DPF, you can check for Patch Communication Manager, table queue, receive wait time, and send wait times. Those are amazing, and you can even write queries to get what is the bottleneck, what weight is the bottleneck as a fraction of the total activity wait time. That's just an idea. So this is something that I use almost on a daily basis. For CPU-wise, mon-get connections is one of the table functions that has the CPU information at the connection level. You can declare global rate temporary tables and then get a differential over X minutes of time and see which connections are consuming the most CPU on your environment. Usually table scans and index leaf level scans within the buffer pool needs a lot of CPU. And like I said in the earlier slides, SQL without parameter markups burns a lot of CPU. And mon-get package cache statement can be used along with WLM to identify the CPU killers.
What's a DGTT for people in the audience?
It's a declared global temporary table. It's a session table that's only specific for this session. So you could actually store the data. Say, I can get the CPU numbers right now at this second, and then I will sleep for 60 seconds, and then I will get another another iteration of the numbers, then I will get basically a differential between writing a query by like subtracting the current values from the values in the DGTT. So
sure. I just didn't recognize the acronym.
Yeah. Oh, okay. Yeah. Sorry about that. I should have. Yeah. But yeah, DGTTs are declared global temporary tables, and there is another version of them called CGTTs, created global temporary tables. There actually will be an entry in the catalog if you create a CGTT. DGTTs are truly session specific, but CGTTs are session specific, but they will have an entry in the catalog tables.
All right. Thank you.
Sure. Few words on WLM. WLM used to be only available with advanced server editions. With 11.5 that changed. It's a great way to. I think it's a great way to monitor the performance of your Db2 server and also manage your workload. It's the best of both worlds. I use it for both my transactional and analytical databases, and I strongly recommend it. It can be used to generate some great reports like this one. So, for example, for the month of November, within this, take a look at the third column from there. It's the service name and how many SQL statements each service is executing, and what is the average time for each of the SQL executions in milliseconds, and what are the monthly service CPU seconds, and what is the share of the CPU for each of those services. And you keep track of these, and if something is off at the end of the month, you can see what changed for that application, and then you can try and drill down and try to find the root cause of the increased resources. And this is a two-page SQL that I wrote, but I will probably create another blog post on WLM, and I will go over this. But it's pretty cool what you can do with WLM. Then we'll go over some of the PureScale specific tips. Lately, I have been working in a PureScale environments quite a bit, and I have uncovered few issues. And also I discovered some of the best practices by burning my hands. So I thought of sharing them with the audience. Monitor for page reclaims at the object level, that is tables and indexes. You can use mon-get page access info. It's a table function as well. Indexes with monotonically increasing sequence numbers tend to cause problems because of they bounce the leaf pages between the members. So to mitigate that, try to add a current member. Try to add a column with the current member as the default and range partition it, and then add the current member, add that column as a leading to the to this index. That will help with leaf pages within the members, staying within the members, basically. So that's the help of it. And also try not to use read stability and repeatable read isolation levels in PureScale unless you need it absolutely. And try to use like smaller page size table spaces to alleviate these page reclaim issues and CF weights. Smaller pages also save you some buffer pool memory. And also, if you're using GPFS 4.1.1 or lower, while creating the indexes, you might see some slowdown across the cluster. That's because we have this setting in the GPFS called worker one threads. So those those threads actually service the IO requests from Db2 actually, and then hand over those requests to the operating system kernel. So they actually, when creating the index, even during the backups and restores, I haven't seen that issue at all. But for whatever reason, when we create indexes, the cluster used to slow down, the bottleneck was identified as the worker one threads on the GPFS side. It looks like the create index process is highly parallel. That's the only reason I could think of on why only create index statement reproduces that behavior. In-place rearcs are not supported on range partition tables in PureScale environments, so be careful about using them. In PureScale environment, lock escalations can happen locally at a member and also globally at CF level. So lock escalations are always exclusive and they'll kill your concurrency. So watch out for CF lock list as well. You can monitor them using monget CF table function. So so like I said, anything these days can be monitored using the monget table functions. And this is an interesting issue that I ran into in PureScale. That just had that guy banging his head to the wall because it's a tricky issue. So be careful when you're writing your updates or deletes using correlated subqueries. Like mostly you write them like in a batch or DPF environments. So I saw a query executing in 5 milliseconds. The same query takes 10 minutes to perform a 2-row delete. So it's incredible. So our replication guys came in and said that, hey, our replication is lagging behind by 2 hours. So I was like, how is that possible? And they say our delete statement is the what's that really taking long. But when I run it, it's really super fast through the command line. But eventually I was able to find the root cause of the problem. But anyway, this is the good plan to your right. So the query is basically trying to delete records from the base table by using a staging table where anything that exists in this staging table will be deleted from the base table. So the query goes something like that. So so if you see in this plan, there are only 26 rows in that staging table, and it's trying to delete on an index lookup on the inner table of the nested loop, and it was pretty fast. It ran in like 5 milliseconds, and it was awesome. And however, this is the bad plan that ran for 10 minutes. So here, see how it's switched from nested loop to hash join, and see how the inner table is now the staging table, and the outer table is now the actual table that we are trying to delete the records from. And also, if you notice why Db2 switched from nested loop to hash, so there are like earlier there are only 26 records in the staging table. Now you have 56,000. Db2 thought, okay, you know, if I loop over these 56,000 records using a nested loop join, it's going to take me a while. So I think hash join is a great idea for this scenario, but apparently in this scenario on PureScale environment, it's not, because how hash join works is, so the reason why the big why. So I was able to reproduce this problem by, at the top, you see how I rewrote the SQL. I couldn't get the optimizer to do a nested loop join, but I was able to force the hash join using an opt guideline. That's a good use case I found for using opt guidelines to force the hash join. Then I get the connection handle for the current session, and then I ran the query in a loop, the third query in a loop on the monget connections. So where I was running it, you could see how the total activity wait time is accumulating, and almost all the wait time is on the CF. That's because with the hash join, the inner table is hashed, and the outer side will be the table that you're trying to delete the rows from. You scan one row at a time and compare and hashed, and basically compares the hash value with the inner hash table. And if it matches, it will try to delete it. But in the PureScale environment, it needs to go to the CF before it hashes the row. It needs to go to the CF and say, hey, this row, did this row change on any other member or not? If it changes, then it needs to get the latest row. So that's why it's doing those many CF trips. If the other correlation that I found is the number of CF trips is almost identical to the very close to the number of rows in the table that I'm trying to delete the rows from when there is a hash join on the left side of the join. So That's a very interesting issue. So if any one of you guys run into this kind of problem, check out for correlated subqueries and deletes and updates. So complete analysis of the problem is in that blog post. These are some of the DPF specific tips. Their query patterns are completely different, scanning and returning large volumes of data, unlike OLTP, where access patterns are like only like tens of rows or hundreds of rows. They use a hash joins and merge scan joins. They need a large amount of sort heap and temporary table spaces. Resource utilization is generally driven by small but very large queries and less number of concurrent users compared to OLTP. Troubleshooting in DPF is a little bit different skill set, but I find it a little bit less obscure than OLTP systems. One of the ways that, other than WLM, I use WLM a lot, but other than WLM, if somebody comes to me right now and says, hey, there is some slowdown across the cluster, these are some of the commands that I use, like starting 9.5, DB2 is a thread-based model. So all the, under the DB2 sysc parent process, you can see what all the operating system threads are running under using these operating system specific PS commands. And then once you get, I basically, this command like 7340372 is the DB2 sysc PID basically. I passed it through a full filter, and then I got this output. I get all the running threads right now where the status field is like basically R means running. I'm just checking, and then CPU that at the OS level, and then kernel thread ID. And then by using that kernel thread ID, I can map it to the DB2 agent by using these DB2 PD commands, and then get what specific SQL statement is running by using the DB2 PD minus DB active statements command, or you can even use a snapshot of the number of ways to get what the agent ID is doing once you know the agent ID. So, but if you're using DB2 PD, that needs to be run from the coordinator partition, otherwise no output will be returned. So another thing to notice on DPF environment is row shipping between the partitions. They can kill your performance. So you need to have your data collocated for your joins, or they're going to slow you down. So you can monitor the row shipping between the partitions by using these table queue operators. And also DPF has this concept called subsections, and they're actually connected by different subsections, or they're connected by table queues. So different parts of access plan can be executed in parallel in a DPF environment. There is different subsections can be executed in parallel. So like I said, they're connected through the table queues. And to identify what subsection is what within the explain plan, you could use DB2 XPLN with the -i flag, and it will give you all the subsections for that access path. And then when you run a global snapshot or use a snapget subsection monitoring table function, you could find, you could correlate, oh, okay, this subsection is actually this table queue, and this is actually sending the data from this table to this table. So maybe then that way you could identify where the bottleneck is. And there is this great white paper from IBM there is some in-depth details about table queues and subsections within that blog. And this is a common problem in DPF. You usually have fact tables and dimensions. But the key is like you partition these tables for performance. So fact tables usually have these dimension keys from multiple dimension tables. I have dimension 1 and dimension 2 here. One is, say, for example, product dimension and date dimension. So for fact table is trying to aggregate some data based on product and date. I made up some numbers there. So if I hash or partition the fact table by one of the these dimension IDs, you will the join to the other dimension will be a table queue. So that kind of slows your queries down. So how do you overcome this problem? Or basic design problem in a DPF environment. So replicated MQTs. So create a replicated MQT on the smallest of the dimensions, because when you create a replicated MQT there, you are basically materializing that table across all these partitions. So that's why it makes sense to create the replicated MQT on the smallest table or the smallest dimension. Usually your tags are large, and you don't want to create a replicated MQT on them because you're going to waste a lot of space. Make sure all these tables are on the same database partition group, or the data won't be collocated. And don't forget the enable query optimization clause of the replicated MQT create statement. And also, this is something like in the DPF environment, it always helped us to design a brand new data model to give it depending on the requirements, rather than using an existing data model and just try to cram in the reporting requirements on the existing data model. So sometimes duplicating the data to denormalizing the data to satisfy a specific report will help. Usually sometimes there will be a conflict when you're trying to design. The ETL guys might not like the design, but I think ETL guys could work around some of those design issues by creating the work tables or breaking down the SQL, but a lot of the times reporting guys don't have the flexibility. So try to design, try to make your design more friendly to the reporting folks. So this is an interesting topic. The SARs, like, they have a really bad rap. So within the DBA community, but it starts really bad. Really, it depends on why you are sorting the data. Really, for example, take this unsorted data. If I want to search for, say, 2 there, from top, this is a list, just a list. I'll be finding 2 at the second row from the second element from the top. But if the data is unsorted, there is no way for DB2 or any other optimizer to know there is not another 2 down the list. So it needs to keep scanning until the end of the list of the table. So sorting speeds up your searches by using algorithms such as binary search or B-tree indexes. So now here the data is sorted. So now here if I want to find a 2, so even if I do a scan from the top, I find 2. As soon as I find 3, I don't have to scan anymore because we know the data is sorted. And here, usually there are a lot of better algorithms than scanning, like the binary search, basically where it divides the range by half. So for example, this is a list. So this is a list of 7, so 3.5. So for example, it rounds up to 4. It's 3. That means I can eliminate the range above 3 because I know my 2 won't be in the range above 3. So I can go and again divide the range before the 3 to half and then do a binary search. It's a lot more efficient. So DB2 needs to sort the data to build indexes, needs to sort the lists to facilitate the list prefetch and facilitates merge, scan, joins, and all these are valid scenarios. Invalid scenarios are like, I have an OCD and I want to sort the data. That's not a good thing to do. Or you could even use write indexes to avoid in-flight sorts. That means because your B-tree indexes, for example, take this table. I made up this table. So tables in most RDBMSs are heaps. That means they're not sorted in any way. It's the same way. Imagine searching for 1 in there. It needs to scan the whole table, which needs a lot of IO and not very efficient. So now if I create a B-tree index on that data right there, see how it sorts the data at the leaf level, the one in the green. So everything is nicely sorted. So that's how the B-tree structures are organized. So helps speed up your queries significantly. Everything comes with a price. B2 slows down your writes a little bit, updates and inserts, because these entries needs to be managed in this data structure as well. And helps your order by queries. Say, for example, if I'm retrieving the data from a table, these all I need to do is, if I am just going by these index keys, I just get the reads in the same order as the keys, and my data is sorted. I don't have to do another sort. So that's why B2 indexes help a lot with sorting. So this is a graphical representation of that test table that I have. When I create the indexes, those reads will be mapped like that to the heap. But you see how those are not exactly in the same. The reads are in one order in index, and they're not sorted in the table in the heap. That's expected. So that's where you get the random IO. If you want to have a better cluster ratio, is what impacts this, how ordered the table rows are when compared to the B2 indexes, index leaf page keys. If you create the clustered indexes, they will kind of line up a lot better. Basically, B2 is like they have the root node, and anything less than or equal to that root node go to the left. Anything greater than. This is not an exact implementation of the DB2's B2 index, but this is a general concept. So you can see why the indexes speed up the queries a lot and helps the order by and helps with sorting. You can actually redundant indexes and unused indexes can kill your performance. Recently, I worked on a performance issue where our top CPU consumer is actually a replication software, and I realized that one of those tables have like 60 indexes, and we dropped quite a bit of them, and were able to bring down the CPU consumption by quite a bit. Last topic we have here today is the SQL tuning. No performance tuning session is complete without the SQL tuning, because majority of the problems really in your environment is caused by bad queries or inefficient design of the data model. So SQL is a language of RDBMS, but it's not a complete programming language. It actually abstracts out a lot of complexities of the regular programming language. That's why tuning SQL might get challenging. It's declarative. I mean, you can tell it what you want, but you cannot tell it how you want it. Although these days we have these op guidelines, you can tell it to some extent on how you can influence the Exp and how it's getting the data that you want. So declarative is something like that. Select ID name from table 1, table 2, where ID equal to ID and name is equal to N with. Imperative is like writing the code to read file A, file B, and filter file A or third field for name is equal to with. Build a B tree on file A and file B on ID and name. Then join them on ID using a nested loop, sort the results using the advanced static sort and give me the results. That's not fun, right? So that's why people like SQL. So it makes your job a lot easier. It's very powerful. Developers don't have to do a lot of that stuff, but at the same time, because it hides a lot of complexities from DBAs and developers, it can be tricky, especially if you write complicated SQL statements to tune them. So DBAs and developers write the SQL, and DB2 optimizer determines how to execute that SQL. That means that's the imperative where it handles all the data structures and the algorithms and how to get it, if it needs to use a nested loop join or a hash join, or if it needs to use an index scan, if it needs to do a list prefetch or whatnot. Run stats help optimizer to determine how to get the data fast. Apart from run stats, there are other ways to help optimizer by writing better SQL. The SQL you write will anyway be rewritten by the optimizer during the query rewrite phase of the optimizer. DB2, in my humble opinion, has one of the best optimizers in the industry. It has a lot of history behind it. It takes care of a lot of these obscure complexities away from DBAs and developers. And finally, make sure your statistics are current to help the optimizer. Remove unnecessary joins and columns not needed by the application. Hibernate and Cognos and some of these tools are notorious for causing issues in this area. Try to avoid expression-based predicates if possible. They'll make the optimizer's job a little bit more difficult. Look for objects that are causing a lot of logical I/O in the plan. Try to fix them. Watch out for cardinality, under and overestimations at various operators. You can try to move the predicates closer to a table, and that helped us a lot in the past. Cardinality underestimations and overestimations are specifically a problem, especially if you have 7, 8, or 10 tables in your query, and if DB2 thinks that I don't have too much data, I'll do a nested loop instead of a hash join. That's going to cause problems, and vice versa. Cardinalities, column group statistics did us wonders, really. I mean, they really helped cardinalities of a lot of our, because the problem with run stats is they run against a table. So DB2 has the data for all the table and indexes. But when you are joining multiple tables, that's where things might get tricky. DB2 will not have that information. How many of these rows from this table with this criteria will qualify in the other table? So that's what these column groups and statistical views will help. Explore things such as CGTT. If you have too much normalization going on and that's causing your performance issues, explore CGTTs and tries to denormalize some of those joins, and use that as an intermediary table within the transaction. If nothing appears to work, look at using opt guidelines. That should be our last resort. More on the column group statistics, I blogged on it again, so you can find some information there. So this is a question that I get a lot of times. How does a good plan look? I think if you take away everything else, I think a good plan should read the least number of rows possible to get the data that you need. So I will put it as simply as that. There are a number of factors that really influence it, like creating nice indexes, and most importantly, the data model and database physical design. How you lay out the tables. If you are joining like 10 different tables to get a customer data, that might slow you down. So there should be a good balance between normalization and performance. So always shouldn't reduce the logical I/O, because no one can guarantee a data or index page to be available in the buffers 100% of the time. When you reduce the I/O, CPU and memory will usually follow the suit. This approach gave me the most success while performance tuning.
I agree 100%. You are spot on. Get rid of that logical I/O and everything else will improve.
Yeah. I learned some of those things from you as well, Scott. So
yes, sir.
Yeah, table scans will cause a lot of I/O, especially when these scans reside on the inner side of the nested loops, because they'll be scanned over and over. They'll not only kill your memory, they'll really kill your CPU. Look for any inefficient indexes in the plan. Ensure that the tables are being joined in the right order. I will explain you why that order is really key. Unnecessary sorting could cause I/O. So take this example. I basically have 3 tables. I'm selecting from 3 tables. Tab 1, tab 2, and tab 3 joining on the ID column, and I have some character data on the second column. Basically, see how I'm filtering on ID equal to 1 on the third table, which is tab 3, which is like correlation MSC. So this is how a good plan should look like, and this is how a bad plan would look like. So good plan will do a lot of less I/O, a lot of filtering up front. It looked up on index on ID is equal to 1, and then joined that nested loop, and they took that intermediary result set and joined to the table 1, and I returned the result set to the user. With the bad plan though, see, usually DB2 would never do this. These things might happen if you have like tens of tables or 8 or 9 tables with a lot of complex predicates. You might see these join orders being messed up and your query is not returning forever. So if you have this table 1 and table 2, so here in the bad plan, the optimizer is joining table 1 and table 2. See how much for each record in the outer side table 1, it is scanning the whole table 2. It doesn't matter if it's an index or table, you're still doing a lookup on the whole structures. And then you're taking that intermediary result set and doing the join to the table 3 and finally applying the filter, which is really not very efficient. So the good plan is like started by filtering on local predicate, which brings back one record with one row, really 3 IOs on a 3-level index. Then join that one row to table 2, then that intermediate result set to the table 3. A total of 3 rows read, and I got my results back. Awesome. With the bad plan, here on the right, I'm joining tables 1 and 2 first, 10 multiplied by 10, like 100 logical rows read, 100 rows read, then carry over those as an intermediate result set. You might need a lot of temp space for that and a lot of memory. Then join those 10 rows to tab 3, resulting in another 10 rows read. A total of 110 rows read, a lots of IO, CPU, and memory. So which is really bad. So this is my last slide. What about SLAs? Before you commit to an SLA, think about it like, so if you say like, my query needs to be returning back the result set in 1 second, that means you should really, like I said, tune for logical IO. So if your query is reading 100,000 rows and it is doing lots of physical IO, because nobody can guarantee that row or a page is always in the buffer pool. So so if each IO takes 1 millisecond, and to satisfy your query, if you are doing 100,000 IOs, so that's like 10 seconds. So is that acceptable? Think about it. Or you may need to revisit your design, or maybe might need to create some indexes or rewrite your queries. There are a lot of things that can be done, but this is a joke here. Why a DBA and developer never gets engaged? Because the developer would not commit. So you can contact me. I know this is a quick session. I had to go through my slides quickly because there is a lot to cover. But if you have any questions about what we discussed today, you can contact me in any of these ways. I usually check my email pretty frequently, so you could send me an email or tweet me at Raghu on Tech. Leave me a comment on my blog, and I'll get back to you.
Well, the first time I reached out to you to talk to you about speaking today, I reached you on Twitter.
Yeah, I remember that, Scott. I was actually surprised that you read my blog post.
Oh, I watch a lot of Twitter activity and follow DB2 things and political things, and silly me. Hey, I had a question for you on that good plan, bad plan that you had just a few slides ago. Let's say that the optimizer has picked the bad plan. What are you going to do to fix that? How do you encourage the optimizer to get a better plan? What's your solution to the optimizer choosing the bad plan?
So there are a few ways to fix it, really. I mean, if you have run stats for as simple query as this would never happen. But if you have a complex query and you see this thing happening, like where the join order is wrong, it's actually joining the tables in the wrong order. Like once the optimizer picks the wrong join, that's it. Your plan is messed up for the rest of the thing because it all gets carried over. So a few things that I would try is definitely I would try to see when my run stats were updated. Then if there are any complex predicates or joins on like multiple columns, then I would definitely try column group statistics. They really help me tremendously because that's where one of the slides I have a blog post on how I fixed because usually when you have the cardinality, underestimations or overestimations, these things happen during those scenarios. If you have these cardinalities sorted out almost close to 100% of the time, DB2 would do the right thing. If the worst case, if nothing works, you try the run stats, you try rewriting your query a little bit by moving the predicates closer to the tables. Like these days, I see a lot of these report developers writing queries like with this lot of CTEs, and they're not filtering until at the end. So when I move these predicates closer to the table, like by creating a derived table or something like that, so I see the optimizer doing the filtering and these things up front, and then only taking the smaller intermediate result set to the top of the plan. And the last but not the least, if nothing works, we have op guidelines now starting with 11.1, and we can influence the join order and also tell it what kind of join to use. But although I would caution against it, I personally used op guidelines in like 2 or 3 scenarios right now that I'm working at. So, but you should really give enough time and enough information to the optimizer before we go that route.
All right. Well, thank you for answering my question. I'm now asking our audience a question if they learned anything today. It's one of the questions we try to ask every show. Let people vote here for about 30 seconds. It's looking good. You had an excellent presentation. Have you presented at IDUG yet?
Oh, not yet. Actually, next year I'm thinking about presenting at IDUG.
I think you should consider submitting your presentation to IDUG. It's very good. Okay, I'm going to close.
Thank you for the nice words.
Close the poll and share the results. Look at that. 100% of our good-looking audience learned something today. That's fantastic. I need to make me the presenter so we can scoot along to the end of the show. I'm going to ask one more polling question. How did you hear about today's show? Let's see if we can get our people to vote here. Trying to figure out the best way to get the word out about the show so that as many people as possible can benefit from the free education. Going once, going twice. We're going to close the poll and share the results. Okay, let's see, a little bit of Twitter, a little bit of LinkedIn. The DataView show newsletter is the most popular way. That's right, put it right in your inbox so you get to look at what's available. Show homepage got some votes in the IBM community. That's fantastic. Okay, next. Any questions? Oh, there is a question. And Raghu, I hope you submit a presentation to IDUG EMEA in Edinburgh. So there you go. You have an international invitation from someone on the IDUG committee in Europe. So I want you in North America and Europe.
Awesome. I'll do that, Scott. I will try to refine this a little bit. I know this presentation is we did it at a little fast pace, but hopefully at IDUG I can spend some time on each of these slides a little bit more, because some of these are a little bit deep in concept.
Very good. Yep. And for those that were smart enough to join us today and attend the live show, the handout is available. Look at the GoToWebinar tool and look at the handouts thing, and you can click on that PDF and get Raghu's presentation. There's always advantages to attending the live shows. And there you go. People are getting your handout. Thank you, audience, for being here. Certainly appreciate you. Had many people, many countries all over the world represented today. Thank you, for Raghu, for your terrific presentation. Very informative. Thank you. Thank you to the IBM community. Definitely a sponsor of the show. And you're going to find your replays and show news at dataviewshow.com/news. That's where we hide the replay information. You can find the replays on YouTube, which they'll be embedded in the blogs here on the news, And we're also putting the replays into the IBM community blog. So you have 2 chances to win and find those. And with that, that is a wrap. That's the end of the show. Raghu, thank you again.
Scott, thank you very much for giving me the opportunity. I enjoyed it.
All right, it was a lot of fun, and we will
thank you so much.
Wish everybody a happy Friday tomorrow and a fantastic weekend. And with that,
Bye-bye.
It's the end of the show. Bye-bye.